Hey there, science fans! Today, we're diving into the exciting world of machine learning. You know how you learn from experience? Well, machine learning is all about teaching computers to do the same thing. It's like giving them a brain boost, helping them get smarter over time. Instead of being programmed with specific rules, these clever machines can learn from data and figure things out on their own. Imagine a computer that can identify different objects in a picture. It can tell the difference between a cat, a dog, and even your best friend. But how does it do that? That's where machine learning comes in. By analyzing tons of images, these computer whizzes can learn to recognize patterns and make accurate predictions. Machine learning is changing the world as we know it. It's used in everything from self-driving cars to medical diagnoses. Pretty cool, right? So, buckle up and get ready for a wild ride as we explore the fascinating world of machine learning. Let's say we want to teach a computer to recognize pictures of cats. How do we do it? It's like teaching a puppy a new trick, but instead of treats, we use data. First, we need to gather a massive amount of data. Think thousands, even millions of pictures labeled as cat, or not a cat. We're talking about a whole lot of cat pictures. This labeled data is like a training manual for our computer. We feed it to our machine learning algorithm, which is like a recipe that tells the computer how to learn. The algorithm analyzes the pictures, looking for patterns and features that define a cat: pointy ears, whiskers, a fluffy tail, you name it. As the computer sees more and more pictures, it gets better at identifying those telltale cat characteristics. It's like a game of guess the animal where the computer gets smarter with every round. Eventually, our computer graduate can look at a new picture and say with confidence, "That's a cat," or "Nope, not a cat." And that, my friends, is the magic of machine learning in action. Supervised learning is like having a teacher in a classroom. The teacher gives the students examples and tells them the right answers. The students learn from these examples and then take a test to see how well they've learned. In supervised learning, we give the computer labeled data, pictures of cats labeled cat and pictures of dogs labeled dog. The computer learns from this labeled data and builds a model that can predict the label of a new unseen image. It's like the computer is learning to take a test and getting better with each practice run. One example of supervised learning is email spam filtering. We can train a machine learning model on a data set of emails labeled as spam or not spam. The model learns to identify patterns and features that characterize spam emails, such as certain words, phrases, or sender addresses. Then when a new email arrives, the model can predict whether it's spam or not, keeping our inboxes clean and safe. Now imagine a child playing with a big box of Legos. There's no instruction manual, no predefined categories. The child starts grouping the Legos based on color, shape, or size, discovering patterns and relationships on their own. That's unsupervised learning. We give the computer unlabeled data, like a giant pile of Legos without any instructions. The computer's job is to find hidden patterns, structures, or relationships within the data. It's like playing detective and uncovering hidden clues. One example of unsupervised learning is customer segmentation. Imagine a company wants to group its customers based on their purchasing behavior. They can use unsupervised learning to analyze customer data like purchase history, browsing patterns, and demographics. The algorithm can then group customers into different segments based on similarities in their behavior, even though the company didn't know these segments existed beforehand. This helps the company tailor its marketing strategies and product recommendations to each customer group, making everyone happy. Section 5. Reinforcement learning. Learning from mistakes. Have you ever played a video game where you learn by trial and error? You try different actions, see what works, and adjust your strategy to get a higher score. That's reinforcement learning in a nutshell. In this type of machine learning, the computer interacts with an environment and learns by receiving rewards or penalties for its actions. It's like teaching a dog new tricks with treats and praise. Imagine a robot learning to navigate a maze. It starts by making random moves, bumping into walls and taking wrong turns. But for every step closer to the exit, it receives a reward. For every wrong turn, it gets a penalty. Over time, the robot learns from its mistakes and figures out the optimal path to reach the goal. Reinforcement learning is used to train robots for complex tasks, like playing games, controlling robotic arms, and even driving cars. Section 6. The Hardware Revolution. Faster, stronger, smarter machines. Remember the days of clunky computers that took up entire rooms? Today, we carry more computing power in our pockets than ever before. This incredible advancement in hardware is a game changer for machine learning. Faster processors mean we can crunch massive datasets in the blink of an eye. Larger memory capacities allow us to store and process vast amounts of information. Think of it like this. If machine learning algorithms are the chefs, then hardware is the kitchen. A well-equipped kitchen with powerful appliances lets the chefs cook up amazing dishes faster and more efficiently. Specialized hardware like graphics processing units, GPUs, is designed specifically for the demands of machine learning. They're like turbocharged ovens, accelerating the training process and unlocking new possibilities. Section 7. Algorithmic advancements. Refining the recipes of intelligence. Just like chefs experiment with new recipes, researchers are constantly developing new and improved machine learning algorithms. These algorithms are the brains behind the operation, the secret sauce that makes machine learning so powerful. One exciting area of research is deep learning. It's like building a multi-layered cake, where each layer represents a different level of abstraction. Deep learning algorithms excel at processing unstructured data, like images, text, and audio, making them ideal for tasks like image recognition, natural language processing, and speech synthesis. Another promising area is transfer learning. Imagine teaching a dog a new trick by building on its existing knowledge of basic commands. That's transfer learning in action. We can train a machine learning model on a massive dataset and then fine-tune it for a specific task using a smaller, more specialized dataset. This saves time and resources, allowing us to leverage the power of pre-trained models for a wider range of applications. Section 8. Machine learning in healthcare. Diagnosing diseases and developing cures. Machine learning is revolutionizing healthcare in incredible ways. Imagine a world where computers can help doctors diagnose diseases earlier and more accurately, personalize treatment plans, and even develop new cures. That's the promise of machine learning in healthcare. One exciting application is medical imaging analysis. Machine learning algorithms can analyze X-rays, kinetic scans, and MRIs to detect abnormalities that might be missed by the human eye. They can help identify early signs of cancer, heart disease, and other life-threatening conditions, allowing for timely intervention and potentially saving lives. Machine learning is also used to develop new drugs and therapies. By analyzing vast data sets of genetic information, researchers can identify potential drug targets and predict how different patients might respond to treatment. This personalized approach to medicine is transforming healthcare from a one-size-fits-all model to a more precise and effective system. Section 9. Machine learning in finance. Predicting markets and preventing fraud. In the fast-paced world of finance, every second counts. Machine learning is helping financial institutions make smarter decisions, manage risk, and stay one step ahead of the game. One of the most well-known applications is algorithmic trading. These sophisticated algorithms can analyze market data in real time, identify trends, and execute trades at lightning speed, often without any human intervention. Machine learning is also used to detect fraudulent transactions. By analyzing millions of transactions, these algorithms can identify suspicious patterns and flag potential fraud attempts, protecting consumers and businesses from financial losses. From credit card fraud detection to loan approval processes, machine learning is transforming the financial industry, making it more efficient, secure, and accessible to everyone. Section 10. The future of machine learning, a world of possibilities. The future of machine learning is bursting with potential. As hardware continues to advance and algorithms become even more sophisticated, we can expect to see even more innovative applications of this transformative technology. Imagine a world where self-driving cars navigate our roads safely and efficiently, robots assist us in our homes and workplaces, and personalized learning experiences cater to each student's unique needs. Machine learning is also playing a crucial role in addressing some of the world's most pressing challenges, from climate change to poverty and disease. By analyzing vast data sets, these intelligent algorithms can help us understand complex systems, predict future trends, and develop innovative solutions to create a better future for everyone. Section 11. Using machine learning wisely. Balancing progress and responsibility. As with any powerful technology, it's essential to use machine learning responsibly and ethically. We need to ensure that these systems are fair, unbiased, and transparent in their decision-making processes. It's also important to address the potential impact of machine learning on employment and the workforce. As machines become more capable of performing tasks previously done by humans, we need to find ways to adapt and create new opportunities for human ingenuity and collaboration. By embracing a future where humans and machines work together, we can harness the full potential of machine learning to create a brighter, more equitable, and sustainable world for generations to come. Remember, the future is not something that happens to us, it's something we create together. Stay curious, keep exploring, and let's build a future where technology empowers us all.